the ratio of mass of lead-206 to the mass of U-238 in a certain rock specimen is found to be 0.5. Assuming that the rock originally contained no lead, estimate its age. Half-life of uranium is 4.5 into 10 to the power 9. So what is our next question over here? It is the ratio of mass of lead-206 to the mass of U-238 in a uranium rock specimen is found to be 0.5. Now students, say your U-238, what it is doing? The rock, in the rock U-238, this is disintegrating into lead-206, right? Now initially when the rock was formed, so when the rock was formed, there was no lead-206, right? There was only U-238, okay? And at time t, there is lead-206 as well as U-238. Now, if I want the amount of U-238 in the rock after time t. Now it would be what? It is present in the rock. Now that we can take it. But initially, say your rock, this has been disintegrated and the rock which you have obtained has what? U-238 as well as Pb206 is there. But this U-238 is the final state, that is at time t. Now what about lead-206? Or what about U-238 at time t is equal to 0? What about this? Now students, whatever lead is there in the rock has come from what? Has come from U-238 only. U-238 only has disintegrated and formed Pb206. It means the initial concentration of your U-238 or the initial concentration of U-238 in the rock will be what? It will be the sum of U-238 present at NT plus lead-206. Because students, we don't know initially the rock had what all concentration. What all we have is this U-238 plus Pb206. Now this whole would have been present initially, and there is final some U-238 concentration present. So we can take that your N naught is equal to U-238 plus Pb206, right? And NT we can easily calculate because U-238 is present, so it is U-238, right? Now we have got the ratio. Now we have got the half-life of uranium, that is 4.5 into 10 to the power 9 years. Now let's solve this question. The ratio of lead-206 to U-238 is equal to 0.5, right? And the half-life of U-238 is equal to 4.5 into 10 to the power 9 years, right? Now what is it? N naught by NT, or let's take up the formula, that is lambda is equal to 2.303 by T log of N naught by N. Now what is N naught? N naught is what? U238 plus PB206. And what is NT? It is U238. Right? Now what will be your lambda? Lambda will be equal to 0.693 divided by 4.5 into 10 to the power 9. And that will give what? That is your 0.693 divided by 4.5, and that is divided by 10 to the power 9. That will give what? 1.54 into 10 to the power minus 10 per year. Now what will be our time? That is the age of that particular rock. That will be 2.303 divided by lambda, that is 1.54 into 10 to the power minus 10, that is into log of initial concentration is what? That is U238 plus PB206, and the final concentration would be U238. Now can we write it like this? T is equal to 2.303 divided by 1.54 into 10 to the power minus 10, and log of 1 plus PB206 divided by U238. Now this ratio we have. So the age of the rock will be equal to 2.303 divided by 1.54 multiplied by 10 to the power minus 10 log of 1 plus 0.5, and your time would be 2.303 divided by 1.54 into 10 to the power minus 10 log of 1.5. Right? So just solve this and you will get your answer. Right? So that comes out to be, that is your age of the rock is equal to, let's find out. It is 2.303 divided by 1.54, and that is again divided by 10 to the power minus 10, right, and multiplied by log of 1.5. That comes out to be 2.69 into 10 to the power 9 years. This is 2.63 actually into 10 to the power 9 years. So what is the age of the rock, students? 2.63 into 10 to the power 9. Right? I hope you have got this concept. This is just the concept of final concentration and initial concentration. Final concentration is U238, and whatever was present initially, U238 plus PB206. Why? Because your PB206 is obtained from U238 only. Right?